Graphing using transformations, part 2. Use the graph of y equals f of x to graph the function g of x equals f of x plus 3 minus 1. So here we have the graph y equals f of x, and we have this picture, and we want to take that graph and graph the function g of x. So g of x is just the graph of f of x with some transformations applied to it. If we look at the equation of g of x, we can see that there are two transformations being applied to f of x. We have the plus 3 and we have a minus 1. So those are two different transformations. The plus 3 is being applied to the x within parentheses. If we have something being applied within the parentheses, that means that our transformation is either going to be a shift to the left or a shift to the right. So in this case, we have a plus 3 on the inside of parentheses. We're going to take the opposite sign and make that shift. So the opposite of plus 3 would be a negative 3, which tells me to move to the left. So again, I take the opposite if it's inside parentheses. So this tells me that I'm going to move left 3 units. Now I'll look at the minus 1. So whenever we have a number being added or subtracted to the overall function, which means it's on the outside of the parentheses, then my graph is either going to move up or down. So here I have a minus 1. So that tells me that I'm going to move down 1 unit. So I keep the sign if it's on the outside of the parentheses, and then I take the opposite sign if it's on the inside of the parentheses. So again, my two transformations are to move left 3 units. That's applied to my x-coordinate because the x-coordinate is left or right. And then my second transformation is down 1 unit. So that affects my y-coordinate because the y-axis is up and down. The first step in applying these transformations is to identify the ordered pairs of your original graph. So I'm going to look at each one of these ordered pairs and write down the xy ordered pair. So here I have negative 4, 0. So I'm just going to write down negative 4, 0. My next ordered pair is negative 2, negative 4. My third ordered pair is 0, 0. My fourth ordered pair is 2, 4. And my fifth ordered pair is 4, 0. Now I'm going to take these ordered pairs and apply my transformation. Remember, my transformation was to move left 3 units and then down 1 unit. So moving left affects my x-coordinate. So that's the first number in my ordered pair. Since I'm moving left 3 units, that means I'm going to subtract 3 from each x-coordinate. So I'll have negative 4 minus 3. And I'm going to do that for every single ordered pair that I have. All right, so I had a minus 2. I'm going to subtract 3. My next ordered pair, I had a 0, so I'll subtract 3. My fourth ordered pair, my x was a 2, so I'm going to subtract 3. And then my fifth ordered pair, I had a 4, so I'll subtract 3. Now I'm going to look at the y coordinate of each ordered pair. And the y coordinate will move down 1 unit. So that means I'm going to subtract 1 from every y coordinate in every ordered pair that I have. So here I had a 0, so I'll subtract 1. Next, I had a negative 4, and I'll subtract 1 from that. Then I had a 0, and I'll subtract 1. And I had a 4, so I'll subtract 1. And then a 0 for the last y coordinate, and I'll subtract 1 from it. Okay, so now I'm just going to apply those operations by subtracting 3 from each x coordinate and subtracting 1 from each y coordinate to get my new ordered pair. Negative 4 minus 3 is negative 7, and then 0 minus 1 is negative 1. So my new ordered pair is negative 7, negative 1. Negative 2 minus 3 is a negative 5, and then negative 4 minus 1 is negative 5. So my next ordered pair is negative 5, negative 5. 0 minus 3 is negative 3. 0 minus 1 is negative 1. 2 minus 3 is negative 1. 4 minus 1 is 3. 4 minus 3 is 1. And 0 minus 1 is negative 1. So each one of these ordered pairs is my new ordered pair of my transformed graph. So these are the ordered pairs of g of x. So now if I want to graph g of x, all I have to do is plot these ordered pairs on the graph. So these are my ordered pairs. So I'll just go ahead and plot each point on the graph. So first I have a negative 7, negative 1. So I'll count over negative 7 and down 1. That's that point. And then negative 5, negative 5. Negative 3, negative 1. Negative 1, 3. 1, negative 1. So these are my new ordered pairs. So I'm just going to connect the dots here. Again, since I only moved my f of x left and then down, the actual shape of the graph didn't change, it just shifted. So every ordered pair shifted 3 units to the left and down 1 unit. So this is the graph of g of x. Now in MyMathLab, you're going to be given 4 answer choices for this problem. And you'll need to look at each graph to see if the graph has your ordered pairs that you found. So here is an example of what it would look like in MyMathLab. And you'll need to select the zoom in button. And when you do that, it will zoom in the graph so you can actually see the ordered pairs and make sure that all of the ordered pairs are that of the correct graph. So if we check this, we just need to check each point. So this is indeed negative 7, negative 1. This one is negative 5, negative 5. Then we have -3, -1. We have -1, 3. And finally 1, -1. So all of our points that we found are on this graph, so that tells me that choice C is the correct answer. So you would just select that and move on to the next question.